SCP Algebra 1, this is Chapter 2, SLI, worksheet number 6, odd answers. So we're going to graph both of these. So we have a 3 here, and we have a 5 here. We have an open dot on 3 going this way, and we have an open dot on the 5 going this way. We're using the word or, so it just has to show you have overlap, but it also goes both directions. So our answer is negative to positive infinity. Problem number 3, we have the word and in here. So I have a 3 here, solid dot, going this way. I have a 5 here, solid dot, going this way. We're looking at the overlap only because it's and. So it's going to be hard bracket 3, hard bracket 5. That's our interval answer. Problem number 5, we have a 0 here, so we have less than 0, and we have a 6 here, and it's going this way. It's or, so we want to know where this is going. So this is going to negative infinity, this is going to positive infinity, so we need two interval notations. So negative infinity to 0, soft bracket, and then 6 to infinity, also soft brackets. Problem number 7, we have a negative 2 here, solid dot shading left. We have a 6 here, open dot shading right. This is, again, this is an or statement, so we want to just show where it happens. That's going to negative infinity, that's going to positive infinity. So two interval notations. This is going to be a hard bracket at the negative 2, but the 6 is going to be a soft bracket because it was did not have the equal sign. So you need both of those is the answer. Problem number 9. We have negative 6 down here. So that's going to be an open dot going to the right. We have negative 2 here. That's a solid dot going to the left. So we're looking for the overlap. Okay, so the negative 6 is going to be a soft bracket, but the negative 2 will be a hard bracket because it had the inequality sign there. Number 11, we have 5. So that's a solid dot going right. And we have 7. That's a solid dot going this way. It's an or, so we want to know the entire thing. So it's going from negative to positive infinity. Number 13, we want the interval and draw the graph. All right, so we have two different things. So I'm going to add 5 to both sides on this one. So I get x is less than 13. I'm going to flip this one over. Make sure you flip the sign as well. Divided by 2, x is greater than 10. So we have 10 open dot going this way. We have 13 open dot going this way. It's an or, but we have total overlap and it going each way. So our interval notation will go negative to positive infinity for our interval notation. Number 15, we're going to subtract 7 from both sides here and here. So I get h is less than negative 2. And then I'm going to divide each side by negative 9. Make sure you flip your sign over because you're divided by negative. And let's take a look at this. So I have negative 2 here, open dot going left. I have 5 over here, open dot going right. This is pointing to negative infinity. This is positive infinity. We only need to know because we have the or, there's going to be negative infinity to negative 2, soft bracket, and 5 to infinity, soft bracket on everything. Problem number 17. Let's subtract 2 from both sides. So I get 3w is less than 3. Divide each side by 3. So w is less than 1. Let's subtract 8 from both sides. So negative w is less than or equal to negative 6. Multiply everything by a negative, so the sign flips over. Let's put this on a number line. So we have a 1 here, open dot going left forever to negative infinity, solid dot on the 6 going right forever. So our interval notation answer will go from negative infinity to 1, soft bracket, hard bracket 6 to infinity. Number 19, now we're reviewing. So let's divide each side by 2 first. So you get the absolute value of x minus 5 is equal to negative 6. Remember, if you have the absolute value by itself and it's equal to a negative number, this is no solution, however you want to write it. Okay, but you have to make sure the absolute value is all by itself before you can declare that. There you go.